Hello, General Math. Sorry I couldn't be in class today. The goal today will be to introduce the next section of your textbook, which is section 5.1. The section is based on ratios. That's fractions or some form of them. We've done fractions before. That was back in chapter 3. Chapter 3 was all about, the practical uses of fractions, how to manipulate them doing basic operations, add, subtract, multiply, and divide. The chapter we just previously did, which is chapter 4, that was all in decimals. How to add, subtract, multiply, and divide decimals and repeating decimals. Well, in this chapter, they're going to be talking a lot about the practical uses for decimals and fractions, how they're related to each other, what do we use them for in everyday math, and to make us better at them, which is kind of the cool stuff, what we can actually use this stuff for. Today, all we're going to be doing is introducing what a ratio is, the definition of it, talk about how to actually use it in certain cases. Now, these are very limited examples, so we'll be done kind of early today, and you can work on wherever you need to. But let's jump right in. Let's talk about the actual definition. So a ratio itself. Ratio, by definition, so let's do the definition here. It is a comparison of two numbers using division. Okay, that's the idea. That's what a ratio is. It's a comparison of two numbers. So now the forms that these can be written in look different, right? I said division, right? Division can be written a lot of different ways. So that's what we're going to be looking at in the next slide. But that's what a ratio is. We're comparing two numbers using division. We just did that a lot in the last chapter. We talked about, repeating decimals. That's a way of, showing two numbers when we divided. We've done it with fractions before, but we're going to talk about the actual examples here. We'll do the forms and we'll kind of walk you through it here. So let's jump to the next slide. Hopefully you have that definition written down. But the different forms of what a ratio is. One of them is fraction form. This is the one that I was just talking about a little bit ago. A fraction can be written like this, right? This is what most people think of fractions. How you type that in your calculator, you can type in 3 divided by 4. As I said, this is a comparison of two numbers using division. Sometimes people write the fraction with, writing the actual fraction with a slant, an actual backspace. But the idea here is that fractions can be written different ways. The more typical one is that top one, right? That's the one that most people always think about with fractions. But it's comparing two numbers using division. Now, the other forms that we have here, let me switch to a different color. We have word form. What I mean by this, you could write a ratio, two numbers compared using division with words. You could write it like this: 3 to 4. Okay, it's comparing 3 to 4 different examples. That gives you an idea. It's using the word to in the middle of it, 3 to 4. You could I know sometimes they use the word per. We'll see that here in an example. That's used in unit form. We'll see that. But that's the second way, using words. The third way is using a colon. Now let me show you that way. I'll switch colors here. Colon method is how your standardized clock would actually use it, your digital clock. They actually use a colon between the two numbers. That is a ratio. It's comparing two numbers. So like on a digital clock, the first digit's your hour, the second digit is minutes, right? But it's comparing them. You're at a third hour and so many minutes. You're comparing something to something. That's a ratio. A lot of people just don't think about that. They're just so used to reading a clock, they don't even think about where it came from. But those are your different forms. The ones we have to get used to is pretty much probably the top one. That's the one that I use probably the most often. But the goal in this chapter is to talk about why do we use them? Like, what's the purpose? And that's what we're going to be doing. I'll try to do some practical application stuff, and I'll try to bring you some examples each day when we actually get to next sections and talk about what we can actually what we can potentially use this for in your everyday life, not just my life. Okay, but let's jump in. Let's actually talk about the unit forms of these, and that's the parts that I want to get to. So the unit form of what a ratio is. Let me switch to a different color here. Unit form is any time that they give you two different labels. So they're going to do a fraction. So let's say 1/4, quarter in like the actual terms of money, you have a quarter, versus 1 dime. So 1/4 to 1 dime. That's a ratio. It's a fraction. They're not in the same form, right? A quarter's worth more than a dime, but we can change them. So we can make them the same units. So if I maybe put them in terms of pennies, a quarter is worth 25 pennies, right? It's 25 cents. Right? A dime is worth 10 cents. Well, what I just did here is I just changed a ratio to a different form, right? Or to a different look. It's still worth the same, but I've now put them in the same form, a unit form. They have the same label, top and bottom, right? That was the whole point, that you can manipulate these numbers. I did change these numbers, but I made them the same values, right? So I made them both into pennies, 25 pennies versus 10 pennies. And then what we can do is we can simplify the fractions. So 25 over 10, right? We can think about like what makes these numbers. So one of the easiest ways to simplify fractions, if you don't have a calculator on you, you can figure out what are the two numbers that multiply to give me 25. Now there could be multiple options, but 25 is pretty easy. It's either 25 and 1 or 5 times 5. Well, I'm going to use 5 times 5. And then the number 10. Well, there's a couple options that numbers that multiply to give you 10. It's either 1 and 10 or what? 2 and 5? 2 times 5. And when you have numbers like this, at this point, now you can see that they have numbers in common. I can cross those out, top and bottom. That's what we did a lot when we were doing proportions, simplifying fractions. You break up the numbers as far as you can, and then you cross out numbers that they had in common, and so your final answer is 5 over 2. That is in unit form, right? It's changing my original problem, which is in quarters and dimes, to the same label, and then you try to simplify it. You can even go further. If you want to divide both numbers by 2, because I know you're going to get decimals, you could get this down to all the way down to 2.5 over 1 if you divide both by 2's. Which anything over 1 is just the number, 2.5. So this is different things we're going to be learning throughout this chapter. Don't feel like you have to know this right now. It's stuff we're going to learn and talk about. But that's unit form. Now, one of the major uses to ratios is doing proportions. Something that we've done a lot in this class. We've done them earlier. Proportions, if you don't know, is comparing two ratios. Ratios using an equality symbol, something like this. 3 over 4, x over 16. That's a proportion. This is a huge concept in mathematics, using proportions. We use them all the time in, obviously general math, algebra, geometry, algebra 2, pre-calc, calc. They're used everywhere. It's just a simple way of manipulating numbers to find missing values. So when you have this number, one of the methods we talked about in class was that you can do a cross product. You start with a number above or below x, so I'm going to start with the 16. You cross multiply and you divide, and it looks like a goldfish, right? Looks like a goldfish. Here's my fish. But again, you cross multiply. You start with a number above or below the x. You cross multiply to the 3, and you divide by 4. So 16 times 3, what is that? 48. And then you divide by 4, and you get 12. Again, you just do that in a calculator. But this number that you're getting here, that number is the x. It's the number that goes here. And that's the missing number. It makes the two fractions actually equal to each other. That's what a proportion is. You're trying to figure out what is the one number that's missing that makes the two fractions actually worth the same value. In terms of like if I was doing a test, I could make a test out of 4 points. You got 3 out of 4. Or I could have made the test out of 16 points, and maybe you got 12 out of 16. They're worth the same grade because the values are the same. That's what the whole point of a proportion is, trying to make two fractions, two ratios actually balance, equal to each other. Now, things we've talked about with proportions, right? One of the major uses for a proportion, is, on maps. We talked about, how you can use this on a map to find distances. We talked about how we can do it for cooking and recipes, that you can scale a recipe up so that it actually can feed a larger party. Because maybe the recipe calls for 4 eggs, and that feeds maybe 3 people. But you need to feed 36 people. Oop, jeez, what am I doing? Put it on the wrong side. You need to feed 36 people. So people are straight across from each other, the same labels, top and bottom, right? So what this proportion will help me with is it will help me with how many eggs I'll need to feed all 36 people. So you'd start with the number above or below the X, you cross, multiply, you divide. And yes, it looks like a goldfish. Here's my fish. But again, 36 times 4 divided by 3. 36 times 4 is a 4 carry a 2. It's a 144, and then you're going to divide by 3. Ooh. Was that 48? If I did that right? I have to check it on a calculator here. 144 divided by 3. 48. That's a major use in proportions. We can scale recipes up. Now, there are certain things you can do with proportions. We talked about this a long time ago, probably chapter 3. Things you cannot use proportion for. You cannot use it for temperature. Temperature, like on an oven. One of the examples I think I used in class was, maybe you're making a frozen pizza, and the frozen pizza itself has to be at maybe 400 degrees Fahrenheit to actually cook. Maybe that's what the pizza calls for. And it takes 20 minutes to cook it at that temperature. 20 minutes. You can't scale this down. You can't say, well, I only have 10 minutes to cook my pizza. Maybe I'm running late and I need to cook it in 10 minutes and then just go. You cannot do this proportion. It will not work. If you cross, multiply, and divide using the little fish method, it will not tell you the correct temperature you need to put on the oven. In fact, if we actually do this problem, you cross, multiply, and divide, it'll take 400 times 10 divided by 20. It's going to tell me that I only need 200 degrees Fahrenheit. I think that's correct. If I type in my calculator here, probably should check that. 400 times 10 divided by 20. Yeah, 200. It's telling me that my temperature on the oven needs to be 200 degrees. In 10 minutes, that won't even de-thaw the pizza. It'll still be gooey and doughy, right? It's not even be cooked. It doesn't work for temperature. So keep that in mind. Proportions do not work for temperature. It does not work for time as well. So I think one of the examples I used in class one time was you're going to be, let's say you're driving to Mason City from Garner, and you're running late to work, and you're trying to figure out like how fast you need to go to get to work on time. This proportion stuff won't work here. We've discussed. Let me give you the example here. So normally, driving to Mason, maybe you're gonna go 55 miles per hour on the highway. You're gonna follow the speed limit, which you should always do anyway. But it takes you 35 minutes to get there. Okay, but you don't have 35 minutes. You woke up late. You have 20 minutes to get to work. So common sense, to find X, you have to speed to get to work, right? Because at 55 miles per hour, the speed limit, you took 35 minutes to get to Mason, but you have to get there in 20, so you have to go faster, right? Maybe 70, 80 miles an hour. Don't recommend that. Don't do that. But if you do this proportion, it won't work, right? If you take 55 times 20, because, right, you always start with the number above or below X, you cross, multiply, and divide by 35, it will not tell you 70 or 80 miles an hour, right? 55 times 20 divided by 35, it's going to tell you that you need to go 31.4 miles per hour. Okay, just to let you know, you might make it to Clear Lake at 31 miles an hour in 20 minutes. Maybe. Okay, you won't make it to Mason. Proportions don't work for time and temp. Keep that in mind. There's only certain things we can do because time and temperature are not linear. I'm going to explain that concept on Monday, what linear means. Time and temp are based on curves, but I'll discuss. We'll bring up a graph with that. But goals today, we're to talk about what we're going to be doing the next couple of days. We're going to be talking about ratios, proportions, playing a lot of games, talking about, because ratios, there's a lot of games that we play, board games, card games, that we can talk about, the probability of winning. So those are things we're going to be doing the next couple of days, and we'll talk about those. But again, hopefully you've learned a little bit of stuff here. We reviewed a little bit proportions. You feel a little more comfortable with what we're going into. Again, Monday we'll start kind of in. We'll talk about homework problems. We'll talk about games you can play and practical uses of this stuff. But enjoy your Friday. Have a good weekend. I'll see you Monday.